Okay, so obviously, if you haven't noticed, the theme of the unit has been like dealing with polynomials in general, and like graphing. Last time we graphed rationals. Today we're going to be graphing exponential functions. Exponential functions are extremely much easier than graphing rational. So exponential functions have the form y equals a times b raised to the x, where a is what I call the initial value or starting point, also known as the y-intercept, and then b is our growth or decay factor. Now the b is what's raised to the x, where x is the exponent. That's what makes it exponential, is that x is in the exponent. If b is greater than 1, it's a growth factor. It's exponentially growing over time. And if b is less than 1, it is decay. Now, I don't mean negative, just it's really absolute value. So basically a fraction less than 1 would be a decay factor. It's getting smaller and smaller over time. So let's look at some examples here. Y equals 1 times 3 to the x. Our initial value would be 1, or our y-intercept is 1. Now think about why this will always be the y-intercept. Y-intercepts are always when x equals 0. If I plug in 0 right here, then that is 3 to the 0, which would be 1. So that's why this would just be your initial value every time. But once again, the math will all work out. So we're going to plug in some points. Let's plug in -2, -1, 0, 1, and 2. So if I plug in -2, guys, that doesn't become negative. I have this. 1 times 3 raised to the -2, which is 1 times by 1 over 3 squared. Negative exponents just get flipped. Do you guys see how that becomes 1/9? So this is 1/9. This will be, plug in a -1, you get a third. Plug in 0, I get 1. Plug in 1, I get 3. Plug in 2, I get 9. So watching me graph that, over -2 up a little bit, over -1 up a little bit, over 0 up 1, over 1 up 3, over 2 up 9. Yep. Okay, so if you look at me connecting this here, do you guys see what I'm saying by it starts out really small and gets exponentially larger over time? That would be growth, which makes sense because look, 3 is larger than 1. Now what's happening, guys, if you think about it, if I keep plugging in negative values, that's just going to keep getting flipped and flipped over our fraction, making it a smaller and smaller decimal. So it's approaching 0, creating a horizontal asymptote. So it'll never be 0. Think about plugging in numbers. It'll just become a fraction smaller and smaller. So all exponentials will have a horizontal asymptote. They don't have vertical asymptotes. So just horizontal. Okay, let's look at doing this exponential decay. It's decay because a third is less than 1, plugging in -2, -1, 0, 1, and 2. So everybody look this one time. If we plug in -2, that would be 1/3 raised to the -2 power. Now think about it. That's 1 to the -2 divided by 3 to the -2. So then we got to flip both. So wouldn't that be 3 squared on top over 1 squared? Does everybody see how it just flips? So that becomes 9. So if I plug in -1, what will I get? 3. Plug in 0, I get 1. Plug in 1, I get a third. Plug in 2, I get a 9th. So as you can see here, if I graph this one now, over -2 up 9, it's just kind of backwards. It's getting smaller and smaller over time. Over -1 up 3, over 0 up 1, over 1 up a third, and so on. Here's my exponential decay function. Questions on that? So if you think about it with this, guys, there is also going to be a horizontal asymptote at 0. So all exponential functions have horizontal asymptotes at 0, unless they've been shifted up or down. Because then think about that, that would change our asymptote, right? So what's the domain for all exponentials then? Where's it growing from left to right? Good, -infinity to infinity, so all real numbers. And our range on this is from 0 to infinity because of our asymptote. So that will only change if I shift things up and down. Our domain, no matter what, if we shift it left and right, will still be all real numbers. But our range is always going to be from 0 to infinity unless I start shifting up or down. That will just change our range. All right, so let's just make sure you're good with growth versus decay. So right here, tell me if it's growth or decay based on the equation. So right here, would this be growth or decay? Growth because 3 is greater than 1. Right here, growth, decay, decay. What would be my initial value here? 1. Okay, good. All right. Now keep in mind, guys, a negative is not going to change anything. A negative is going to be, look, let let me just show you this one time. If I have negative 2 raised to the x, that is actually negative 1 times 2 raised to the x. This is just a reflection over the x-axis. Agreed? Yes.
Quick question about range.
Yeah.
So could you just say that it's from whatever the horizontal asymptote is?
Yep. Yes, unless it's been reflected, because then it might go to negative infinity. So we'll just pay attention to those things. But yeah, absolutely. It's going to be the horizontal asymptote to infinity or negative infinity to the horizontal asymptote. Great inference there. Okay, so looking here, guys, I just want to show you, like, depending on the decay, growth factor, it doesn't change the fact that we have a horizontal asymptote at 0. All it changes is how quick it goes up, how quick or how slow it grows exponentially. So look at the red function and the purple function. Both exponential decay. Do you guys just see how one decays a little bit quicker? And then right here, growth, and then just notice it grows a little bit quicker, green, because it's base 3 versus base 2, but it still all looks about the same. So just once again, our horizontal asymptote is always going to be 0 for exponential unless shifted up or down. Domain for all exponentials, period, end of story, will always be all real numbers. So let's see how easy it is to graph, and then we're going to be getting pretty done with the lesson pretty quick here. So this is how we're going to do it. You'd say, okay, right here is a exponential function, which parent function is base 2 to the x. It's been shifted up 1 unit. Agreed? So what I want you to do is just follow the same theme through the year. You would write down the parent function points. So plug in negative 2, negative 1, 0, 1, 2. So I plug in negative 2, I get a fourth. Plug in negative 1, I get a half. Plug in 0, I get 1. Plug in 1, I get 2. Plug in 2, I get 4. Now we're shifting up 1. So won't we take our y values and add 1? So our new x, y points would just be, the x's didn't change, negative 2, negative 1, 0, 1, 2. And now we're going to have 1.25. Decimals are easier to plot. So 1.25, 1.5, 2, 3, and 5. Does everybody see here? Now, what would I be able to draw in my asymptote as now? It was at 0. Now it's at 1 because it shifted up 1. And then you're going to see your points are going to all work out. They're going to be close to the asymptote. So negative 2 up 1.25, which makes sense. We're right above the asymptote. Over negative 1 up 1.5. Over 0 up 2 units. Over 1 up 3 units. Over 2 up 5 units. And then you would do as many points as that can fit on your graph. And isn't that all? If I needed another point, plug in 3, you get 8. So we get out 3, 9. So over 3 up 9, right up there. So exponential growth. Domain is for all exponentials, all real numbers. Agreed? My range is now 1 to infinity. Notice I put parentheses because this horizontal asymptote won't get crossed. Now we know for rationals that's not necessarily true. If horizontal asymptotes can get crossed, but for exponentials it won't ever cross. But it's not a huge deal. Just keep in mind this will be a parenthesis. Does that kind of make sense? Okay, so it's pretty easy. Let's just do a couple more shifts so we can see what's going on here. So with this one, you'd say my parent function is base 2 raised to the x. Once again, the same x, y points, negative 2, negative 1, 0, 1, 2. So that is 1/4, 1/2, 1, 2, 4. And then this is a reflect over what? The x-axis. Good. So if you think about a point getting reflected over the x-axis, that changes your y value. So you'll times your y values by negative 1. So our new x, y points, negative 2, negative 1, 0, 1, 2. Now look, 1, negative 1 times a fourth is negative a fourth, negative a half, negative 1, negative 2, negative 4. Now we didn't shift up or down at all, so our horizontal asymptote is still at 0. And then watch me graphing this. So over negative 2, down a little bit, over negative 1, down, over 0, down 1, over 1, down 2, over 2, down 4. Is this one growth or decay? Growth or decay? It's still considered growth, everyone. So this is greater than 1, so it's still considered growth. Because technically it's still starting out small and getting larger. Domain is still all real numbers, but because it was reflected, our range is now negative infinity up to the horizontal asymptote of 0. Pretty easy for everybody? Yes? Yeah, yes, and you just got to make sure the fraction's actually smaller than 1. Like, yeah, exactly. Like, 3 halves. Or, because if it was Oh, no, yeah, 3/2 wouldn't, right? Because that'd be 1.5. So you just gotta watch out is what she's saying. Okay, this one is a right one. Did it change my horizontal asymptote? Nope, it wasn't shifted up or down. So then we would do the same thing, base 2 to the x is xy points. So right 1, we'd add 1 to our x's. So that would be -1, 0, 1, 2, 3, and then our y's didn't change. So notice, guys, look, it just shifted to the right, but that didn't change much. Besides, it's just further to the right. So -1 up 1/4, over 0 up 1/2, over 1 up 1, over 2 up 2, over 3 up 4. So there it is. So domain is still all real numbers. Range is still 0 to infinity. Shifts left and right will not affect your domain and range. So let's just do one with both shifts, and then we'll call it good for graphing. This will be our last example of graphing, and then we're actually only going to have one more example. Okay, so right here your parent function would be base 3 to the x. You'd write down those xy points. So -2, -1, 0, 1, 2. So wouldn't this be a 1/9? A third, plug in 0, you get 1, plug in 1, you get 3, plug in 2, you get 9. And then from here we're going to right 2, so we take our x's and add 2. Our y values are going down 5, so we'd subtract 5. The first thing I would do before graphing any points is drawing your new horizontal asymptote at -5. Does everybody get what I'm saying here? Yes. Okay, cool. So now x, y points. So -2 plus 2 is 0, 1, 2, 3, 4. A 1/9 minus 5 is -4.8 roughly. -5 plus a third is -4.6 roughly. 1 minus 5 is -4, right? 3 minus 5 is -2, and then -5 plus 9 is 4. So watching me graph that here. Over 0, down 4 in a little bit. Over 1, down 4 in a little bit again. Over 2, down 4. Over 3, down 2 units. Over 4, up to 4. And I can see my exponential growth happening. Domain is still all real numbers, but now our range is -5 to infinity. You guys feel confident graphing any exponentials? Okay, awesome. Just start with your parent function, shift it. Okay, awesome. Write this formula down. So this is a formula for interest. Getting interest, gaining interest once a year, twice a year, 3 times a year, as many times a year as the bank will offer you. So right here, this is the formula that we will use. Y is equal to P times by 1 plus R over N raised to the NT. You will need to have this formula memorized going into your exam. A lot of memorization going into this exam. So P is the principal or put down amount. That's like our initial value. Notice this has the form of an exponential. R is our interest rate. Now normally when we've done interest rates in the past, if I say we gain interest by 80%, we know we have to go 1.8 usually, right? Because that would be 100% back plus 80%. But notice the 1 in this one's already built in. Do you guys see how they built it into the formula for you? So you would just do the normal interest rate. Like if it was 80%, you'll use just 0.8. Once again, the 1's already built in. N is the number of times you gain interest in a year. They call it compounding. When they say, like, instead of saying you're gaining interest 3 times a year, they say you're getting interest compounding 3 times a year. So compounding just means gaining. The number of times per 1 year. And then T is the time in the account. So once again, N is the number of times you gain interest in 1 year. And then T is time in years. So once you have this formula down, we'll just do one example and then that'll be the end of the lesson. And it's just going to be plug and chug. Okay, so right here it says, the sum of $1,000 is invested at an interest rate of 12% per year. Find the amount in the account after 3 years if interest is compounded annually, semi-annually, quarterly, monthly, and daily. So we have like literally 1, 2, 3, 4, 5 different answers here. So we would say, okay, our put down amount is 1,000. Then we have 1 plus our rate is 12%, so 0.12. divided by n is the number of times it compounds in a year. So annually would be how many times a year? Once, right, everyone? Raised to the nt, so 1 times, and then the time in the account is 3. So you'd use your calculator and calculate it. Let's do semi-annually. So you'll have 1,000 times 1 plus 0.12. Semi-annually means twice a year. So we'd say divided by 2 raised to the 2 times 3. You would calculate it. So let's do quarterly. How many times in a year would that be? Yep. And do you guys get the picture here? Okay, awesome. So then monthly right here would be a 12 and a 12. If I said daily, you'd put right here 365, 365. And then you'll just type it into your calculator. Type it into your calculator. Now some of you need to realize that because you have those little, like the not so great calculators, you might need to actually take your calculator and actually figure out what that is. Write that down. You know what I mean? Calculate that so you can type it into your calculator like 1,000 times by, like right here, this would be, like if I was doing this one, it would be 1,000 times 1.12 raised to the 3. That way you can type it in right. You might need to kind of simplify in sections. So just so you can type it in right in your calculator. Okay, do you guys feel confident to do the homework if that's all you are going to have? Okay, cool, that's the end.